I asked you guys to break this expression into terms and then like terms. So first of all, how many terms are in your list on your bell work? Abby? And then with the list of in the list of terms, can someone share with us, is there any like terms? Blaney?
2n and 7n.
Negative 2n and positive 7n. And then obviously the other pair would be what, Miss Abby?
Negative r and 10n.
All right, now I'm going to ask you to do one more thing. Even though it's not in the directions, is actually simplify this expression. What does that mean? If I ask you to simplify an expression, what am I asking you to do? I mean, like, what does that mean? Scribble?
To combine their terms.
Yep, just combine the terms. So put the n's together and the r's together. What do we have? What's our new expression? Dylan, what do you got?
5n plus 9r.
All right, so we're going to put these n's together. We get 5n. We put these r's together. We're going to get positive 9r. And remember, you have to have an operation symbol between the two terms. This connects these two terms. Now, you have homework. I want you to leave it out on your desk. I will come around and collect it when I have time during the lesson. Okay, when I have you guys try a problem or so forth. So put it off to the left or right hand side of your, just make sure it's visible so I don't sit there and go, do you have your homework? And you just stare at me like a deer in headlights. Just give me the work. I don't need the worksheet if you don't want to give me the worksheet. If you want to give me the worksheet. Well, what is the on All right. I'm ready to start when you are. And I will probably go up to the bell or very close to it. I am getting my money's worth. Or you're getting my, I don't know, I'm making my money worth. What is that? I don't ignore me. Don't look at me like I'm nuts. Nathan, somebody asked me if I took my crazy pills today, and I said, maybe. Maybe not. Maybe I'm just naturally this way. I'm not telling you my secrets. Nor would you care.
Are you going bananas?
Are you recording?
Sure. Go home, have some entertainment.
Yeah, let's do it.
All right, now, this is what's going to happen. I have basically about 4 different types of situations that kind of go with combined like terms in the equations and distributed property. Okay, so the first couple of problems we're going to take care of today. We have a couple situations that I don't think I'm going to get to today, which will go tomorrow. All right. Thursday, I know it's the end of the quarter. We're done with, obviously the second quarter Thursday, and it's not a Friday. We're not going to have a quiz, but we're going to do like an in-class work day. I know you guys have a 3-day weekend. I do not. So, I don't know if you guys have ever done color by number. Okay. So basically what we're going to do is we're going to end this equation unit by doing a color by number activity in class on Thursday, and it's due on Monday. That's going to be your first assignment of the third quarter. So you don't want to not do it because you'll end up, obviously, what happens. Well, remember I told you mathematically, the first 2 weeks you don't want to forget your homework. The first 2 weeks kind of you build that cushion of points, and just in case you have a bad day, you'd rather have a bad day later in the quarter than earlier in the quarter. It's harder to raise your grade than it is to drop it. Drop it 1 grade, boom, you're done. Okay, you can go from A to a D or A to a C with 1 assignment. If you go from C to an A, it takes 15 assignments. Okay, so it just takes so much longer. So I don't want you guys to dig that hole. All right, we're on the home stretch here. After this quarter, we're our on the home stretch here. We've got 2 more quarters to go. So, student will be remember. Okay. Yep. All right. So the first thing that I want you guys to notice today, starting today and forward, okay, I want you to expect that when you look at equations, they're going to look a little bit different than the ones that you had before, okay? If you notice, right now I want everyone to box the variable term in this first slide, please. And you should notice something. What do you notice? How is this situation different than any other problem that you've done? Hayden? There's two. What else do you notice? Anybody notice anything else? There's two variable terms. Dylan?
There's two constant terms.
Yeah. Let me just share something with you. This is like the equation code, okay? Like the rule. Before you can start creating zero pairs, before you can get rid of any operation, before you can start the equation process, period. There's something that we just did on our bell work that I asked you to do something to the expression, did I not? Did I not ask you to simplify the expression? Right? In your bell work today? Every equation from this day forward, you have to make sure, you ready for this? That an equation, you look on the left-hand side. Before you can start, you have to simplify. The most you can have on a side is one variable term, one constant. You can have less than that. That's okay. But I don't think the left-hand side meets that criteria. Do you? It violates the code of equations. You cannot start using the equation process until you simplify. You only can have one variable term on the side and one constant. Okay? You can have less than that, but no more than that. So let's do that. Let's simplify the side. If you simplify the x terms, what do they become? What's our new x term? Dylan?
2x.
2x. What's our new constant if you put the two constants together, Delaney?
Negative 4.
-4. Now once you've done that, what do you notice? Does this problem look familiar?
Yes. Yeah.
Could you solve it from here?
Yes.
Do it. Stop at the check. I will help you with the check. It's a lot faster when you do it. Oh, geez, what did I do? Sorry, kids.
Wait, do the check and then wait?
No, don't do the check. Hmm? Why did I do that?
Yeah.
Should be -8.
Yeah.
Sorry, kids.
Oh,
Again, it's the
sorry.
end of the
Oh,
day.
please erase it. Please erase it.
It's the end of the day and my brain's starting to go. All right. Now, is everyone okay so far?
Yes.
Now, I want to ask you something. I want to ask you, some of you have good instincts in here, and I want others of you to learn from that. Do we check with the top equation or the second equation? Which one do we use to check? Rachel? Why do you think that is? Why do I make you do the one that's original? Think about it. Think about it going from the top to the second equation. What could happen? Alex? What do you mean different? So you're telling me that you might, when you combine like terms, have you ever made a mistake? Have you ever forgot a sign or combined them wrong? Sure you have. So do you see how, what if you combined your 9x and -7x and you put a -2x? Do you realize that this whole process would work and you would get you would actually get this, this -8 would be a +8. It would have worked out. And then you would plug that back in right here. It would be like, I got the right answer. Yeah. And you think you were all that in a bag of tricks. But guess what? You come back to class the next day, and guess what? Mrs. Allen says it's -8, not +8. Like, ah! Well, guess what? Then I tell you, well, you combine like terms here, and it's wrong. Well, where did you check? I checked it here. No. Because if you would have checked it up here, it wouldn't have worked out. All right, so let's check this. Let me show you how this is done. It's a lot of work. No, it's a lot of, I don't have a lot of space like you guys have. All right, so we're going to do this. We got 9. We're going to put in parentheses our x. Now, if you look at the left-hand side of the check, I plugged in -8 where the x's were, and it's basically just a big gems problem. Right? I mean, really, it's just the funnel. It's just a big gems problem. So what operation would we do first? I see what? What are we going to do? Emma?
Multiplication.
Yeah. So what's 9 times -8? Huh? -72. What's -7 times -8? Let's get rid of all the multiplication. What's -7 times -8?
56.
56. I don't have room to do all that. That's a 20. There it is. See it? See it?
I think so.
All right. Now, if you guys look at what's left, do we have any multiplication left?
No.
Okay. All we have left is subtraction and addition. Otherwise known as what type of numbers? Positive and negative. You guys remember what we can do from here? Do we have to go left to right? No. What could we do? Remember when we got the red and the blue pens out? What did we do with the positive negative numbers? Anybody remember? Haley? Yeah. Couldn't you just group all the positives together, then all the negatives, or vice versa, and then find the difference? Remember doing that? Remember how we circled all the blues and then wrote them in blue? Remember? All the positive numbers and all the reds we made negative, wrote them in red. Remember that? Back in the back in the day, you still yeah. All right, so let's do this. I got -72 and -5. If you put all those negatives together, what's our new negative number? How many negatives we got? Abby? -77. We're going to put a positive 1 with the 56. How many positives do we have, Delaney? 57. Now look, these two numbers have to be -20. First of all, -77 and positive 57, which one's the largest absolute value? Yep, so our answer is negative. What's the difference between 77 and 57? Yeah, so there's our -20. So I know the check looks huge, but you can like if you got multiplication in 2 places, do them at the same time maybe. That might help. Okay? Any questions on that? All right, let's do the next one. Huh? Gotcha. Right there. What?
You just tricked us.
I know. Thought we weren't going to do anything, but now.
It's not very nice.
Well, I never said I was nice. Did I?
No.
No.
That's a good point you got there.
I told you to figure that one out on your own.
I'll find a comeback, don't worry.
All right. All right, so remember the first thing you have to do is simplify both sides. What's the problem with this equation? William?
There are no consonants.
Oh, it doesn't matter. We don't have to have constants on both sides. Remember, what is the rule? You're only going to have how many? Variable terms and yeah, there you go. So we're only going to have one variable term. And look at the left-hand side. How many variable terms do we have on that side? 2. That doesn't meet the criteria. Malia, when I said when I say no more than one variable term and one constant, you actually can have less than that. You can have no constant on a side, or you can have just a constant and no variables on a side. Whew, that was. I didn't mean that. I was. Huh?
I just saw that coming.
Did you see it coming?
Yeah.
Yeah. We're gonna keep that off the video. And that was really bad. All right, so when we put these x terms together, what do you got? What's the new x term? What do you got? How many x's you got? Emma, you're just a smiley little thing today. What's up?
8x.
Yeah. Yeah. Are you happy to be here?
Sure.
Well, it's 8th hour.
Yeah.
It's happy to be in 8th hour. You know, you see the end, right? Okay. So now, once we simplify that side, does each side have at least one variable term and one constant, or less than that? We good? Both sides simplified? Another thing that I always, when I was a student, I always said, do I have any like terms on the left-hand side that we can combine? Do we have any like terms on the right-hand side? Can we combine? No. If you say no, we're good. Now we can start our process. Now we can get rid of operations. Okay? What is the operation that you see? What's the only operation that you see? Darian? Yeah, and how do you get rid of multiplication? Yeah. So all we're going to do is now, all we have is division. And what are we going to divide by? 8? Jen, you agree?
Yeah.
All right. She's holding her head up. Long day? Yeah. Yeah.
She's really loud.
Who?
She's really loud.
Jen?
Yeah, she's being really like.
Really obnoxious.
Yeah. She's, oh snap!
Her?
She's really talking to me.
Are you hearing things?
Yeah. Oh snap! Well, she's talking.
Did you get dropped on your head as a child?
I did. Actually, I fell out of the window.
I did.
I was building
On
my
purpose
new,
or?
No, not on. Well, this is what happened. I was building. My
Everybody
new
at home,
house,
listen. Nathan has a story. Go.
and we're building the house, and there was a big window. We had one big window. There were like 2 little ones. On
What
the side.
floor?
It was the big one. Yeah, it was high. It was like, yeah,
First floor?
Second.
Oh, okay.
It was
Second
like
floor.
it wasn't a high second, but
Everything's coming to now. I understand.
anyway, the windows weren't screwed in yet.
Everyone see how this all is working out?
And my dad was talking to the construction workers in the living room, and all of a sudden I crawled to the window, and the window flips over. I fall outside, but years later, we had cement there, but since it was getting built, it was all mud. So I fell in the mud. And
Did you do a face plant?
I have no idea. I don't remember. But
What are you
my
gotta get that from your
dad said he just came sprinting out and grabbed me, and took me to the hospital. I'm dead serious.
I now understand.
Okay, good.
Well, that was semi-bodily.
Why you are the way you are.
Cool.
Just kidding, buddy.
Sorry.
Now, obviously, again, we don't check from the red equation. We go back to the black equation, and we plug in our x values. And again, I only see 2 multiplication, right, and addition. So at this time, guys, I don't mind. We're not doing gems, you know, when I made you do 1 step at a time, okay? We're doing some checks. It's supposed to be, I want it as quick as possible. I'll let you, if you want to, get rid of all, left to right, doing all the multiply and divide first, you know, and so forth, okay? So let's do all the multiplication first. So what's -5 times -8? 40. And we're going to add, we don't add yet, but we can take 13 and times it by -8. Anyone got it for me, Renee? Awesome. And again, we have different signs. So which one of those has the largest absolute value? The negative. And again, since they're different, we're going to find the difference with the difference between 40 and 104. Hopefully it's 64. If it's not 64, I should be teaching, and you guys should be in my class.
So we get to go home.
That was a good vine, not a hello.
Oh.
Yeah, exactly.
So that's a yes?
You didn't get that.
That's a yes.
Dylan, let's just move on. Let's pretend you didn't say anything. All right, now, so the second type of equations that we're going to cover, guys, are equations that obviously are going to have a property that you've done in the past. I believe you guys know what it is to distribute. You've done it. You did it on your last test. And this is the final situation, like I said, that you're going to see. Okay? There's several different, I guess, situations that fall in the distributive category that I'm only going to do these type, and then I have 2 other types of distributive property problems that we're going to cover tomorrow. Is that cool? And if you look at your notes, as you go through the notes, you'll notice that they get more complicated as you go. In the last 2 slides, the kids got scared, but I'm going to show you, and I'm going to blow your minds tomorrow. I'm going to say that for a Wednesday. All right? Today, you guys are good to go. Now, first of all, distributive property. You guys agree that right now x is stuck inside the parentheses. You guys agree? You guys see x is stuck inside. There's only one way we can get x outside the parentheses. It's called the distributive property. Anybody want to remind us how to use it? First of all, what does it mean? What operation do you use when you distribute? Emma?
Multiplication.
Mm-hmm. What are we going to distribute? Renee? 4. Remember, it's the number outside the parentheses. And when we distribute a 4, it means we're going to distribute a factor. A 4 and a factor in a multiplication problem. Okay? So we're going to take that 4 and take it and attach it to and multiply it by x. Okay? And when we do that, 4 times x becomes what? 4x. And then we're going to multiply 4 times 5, which becomes 20. Again, we're right back to where we were yesterday. Correct? Do not solve this problem. We're going to move on. All I'm asking you, you guys know how to do this. Why are we wasting time? All you haven't practiced in maybe a couple weeks is the distributive property, okay? So let's continue, and I'll show you how to check one in just a second, okay? The check is where, again, you've never checked one with the distributive property, correct? So I'm going to show you at least a check so you guys can practice that. All right. On this one, all I want you to do is rewrite the equation without the parentheses. So use the distributive property, rewrite it and get rid of the parentheses. Go. Okay. What? Oh. Okay, Punjab. Annie? Oh, you guys.
I know
Annie. The original Annie?
Oh,
Yeah.
Annie. This morning? Punjab?
Yeah.
Oh, is the guy the guy that he, like has things floating in the air and stuff. He's the bodyguard. Yeah. Yep. He takes the head wrap down and saves Annie.
on the bridge.
We've watched Annie the last 3 nights. So today, no, actually my daughter did, and I told her, I said, you're not going to like it. Once you see the original, you're going to like the original better. I don't like when people redo things. Original's always better. Okay? So today, it was cloudy, and I think it was like 5th hour or 6th hour, and I sang, the sun will come out tomorrow. And all of a sudden, it was like, poof.
Yeah.
And they're like, and they were just like, oh my God! I go, I so made that happen. I was like, Mate! You alright?
Yeah.
Who's trying to left hand his?
I have no idea.
Right. Did you get a little excited?
Yeah.
Were you trying to do the magic of your own or what?
Yes.
If you weren't here, Ryan Phillips is Right, are you alright? Seriously?
Best video ever.
I don't know if I'm putting this one on. You sure? It's like when I tripped over the cord when the kid's like, where'd she go? All of a sudden I looked over, he wasn't there. Alright, back to reality. I still got more to teach here. Thanks, Ryan, for breaking up the monotony. I appreciate that. It's great. It was so part of my lesson I needed to do it. It was right on. Alright, so hopefully you checked that one because I already went through it. Did you guys check your slide? Oh.
Yeah.
I did both.
Oh, Ryan. Oh.
Ryan! He gets buckets.
They probably call him Jimmy G.
No.
All right, everyone good with this slide?
Yes.
Yes.
All right, next. Now we're going to stop here. I want you to distribute. First of all, think about what you're distributing and what you're going to be distributing to. So, first of all, could someone answer what term are we going to distribute? Gates? The 2. We're going to distribute the 2 to what terms? Abby? 2x and the negative 5. What about the positive 4? Huh?
No.
No, because is positive 4 part of the group?
No.
No, so he doesn't get to be included. Get that? Remember, think about what are parentheses? Don't they group things? If you're not part of the group, you don't get a factor of 2. Sorry. So, well, I'm just saying. That's the thing. I don't want you guys to get distribute happy and distribute everything a 2. No, it's only people in the group. Okay? So we got 2 times 2x, which is 4x. 2 times negative 5, which is a positive 4.
What you doing there, buddy? Eat this up. Leaving spell on it.
I'm the funniest person in this room, and I always do not try to compete with me. Do you understand?
Now, can we start with the 0 pair?
No,
Why, Francis? What's wrong?
because we're only supposed to have 2 with the there's only supposed to be 1 with the
Constant. One variable. We have one variable term, which is good. And we only can have one constant. So what is the constant going to be? We have our 4x. What do those 2 constants make? Hannah?
-6.
Mm-hmm. All right, solve for x and then stop, and I'll help you with the check. Okay? Go. And this 9 should be a 10. Yeah, that is why.
Oh.
The 9 should be a 10. I don't know why. I apologize. It was a typo error. I have to. Now it's not going to work. Oh, it's because my look at my scarf. A little fancy with it. All right. I'm like, why is it not writing? It's writing with my. Alrighty then. Okay. Oh, funny. Maybe not. Are you doing the claw or what? Like this.
Meow.
Really? So what does x equal? What does x equal? 4. All right. Now, the only thing that this changes is obviously we have grouping symbols. Have you ever done a GEMS problem with a grouping symbol?
Yes.
So in your check, that's all you have to think about. Remember, when you have a grouping symbol in an expression, remember, within that parentheses, remember, we have to make that parentheses down to 1 number. All right, so I'm going to put the check in, and I'll show you how it works. All right, so here we have 2 times our x, which is 4, minus a 5, plus 4 has to equal 10. Again, if you guys look over here on this, just focus inside. You have multiplication and subtraction. What do you do first? Yeah, can you multiply and then subtract in your head? So simplify it for yourself. Instead of like, when we did the GEMS, remember I had to do 1 step every time, and I made you do that? I think most of you can probably do like 1, 2 steps at a time. If that's okay with me, to shorten up the check. Because remember, the check is just a quick check. A quick mental check is am I right? Okay, so I don't mind in your checks you can combine some operations. All right. So let's do this. What's 2 times 4?
8.
Minus 5 is?
3.
There you go.
You do 2.
I did 2. 2 times 4. Now I have the 2 out here. I just brought the 2 down.
Oh.
Okay. Equals 10. Now what do we have left? We have multiplication and addition. What's 2 times 3?
6.
Plus 4.
10.
Yeah. Can you see how I'm doing a couple of operations in my head? I don't mind if you do that. Now you can do one up, if you want to do, separately, that's fine. But I think most of us can do a couple things at a time and do okay with that. You see?
Oh. Yeah.
You got it?
Yeah.
Leah, you good? Did you see? Can you see? Okay. You want to do one more? Or you guys think you got it? Got it? Now, if you guys look at this real quick, obviously we're not doing that one. We're not doing that one. But here's the situation. We've done this before, but I'm just going to refresh your memory tomorrow with that. Okay, having just a negative sign outside and distributing a negative. We're going to do that tomorrow, and then we're going to distribute a fraction. Okay. Now, a lot of kids stop here complaining. Otherwise, I'm going to give you more. Now, look. I want you guys to look at this real quick. Let me just so that you guys don't come in with bad attitudes, because I can't stand bad attitudes. Remember what I've always told you about a fraction. A fraction is a multiplication problem and a division problem in one. It's like BOGO. Do you know how to multiply by 2? Divide by 3. Watch this. 2 times 6. In your head, what is it? 12. Divide by 3. 4 times x is? You just distributed 2/3.
Oh man.
I just forgot.
You just did it in your head. I just multiplied by 2, divided by 3. 2 times 6x, 12x. Divided by 3, 4x. 2 times 9 is 18. Divide by 3, 6. You just distributed it 2/3. That's why fractions are a piece of cake if you think about it the way that I do. And that's what we're going to go over tomorrow. Your mind